From a distance, Earth appears serene, a sphere of blues and whites turning steadily beneath the sun. Yet that calm hides the single movement on which all life depends. Each revolution of the planet distributes light and temperature, drives wind and ocean, and arranges the rhythms of biology. Without rotation, Earth would be divided eternally between fire and ice, a lifeless body in orbit. The world turns, and because it turns, it lives. The roots of this rotation lie in the formation of the solar system about 4.6 billion years ago. A cloud of gas and dust collapsed under gravity, conserving its angular momentum as it contracted. Out of that disk, the Sun and its attendant planets condensed, inheriting the motion of the original cloud. Earth's present spin, one full rotation every 23 hours, 56 minutes, and 4 seconds, known as a sidereal day, is a remnant of that early cosmic dance. The same momentum that shaped stars and galaxies continues within the planet itself, unseen yet indispensable. Rotation governs the alternation of day and night, the most ancient rhythm known to life. As the planet turns, sunlight sweeps across continents and oceans, heating, cooling, and setting air in motion. The gradient between illuminated and shadowed regions creates pressure differences, wind forms, weather emerges. Without this daily redistribution of energy, one hemisphere would face unending day and blistering heat, while the other froze in perpetual night. Between them would lie a perpetual raging frontier of storm. Only Earth's regular spin softens these extremes into the moderate climates where organisms can thrive. Deep below the surface, rotation performs another critical function. The planet's metallic core remains partially molten, stirred by convection, and influenced by the Coriolis force, the deflection of motion caused by Earth's spin. These flows of liquid iron generate a self-sustaining magnetic dynamo. The resulting magnetic field extends far into space, deflecting the solar wind, a continuous stream of charged particles emitted by the sun. Without this shield, those particles would strip the atmosphere molecule by molecule, as happened on Mars long ago. The auroras that shimmer near the poles are the visible trace of that defense, a silent dialogue between rotation, magnetism, and solar energy. The importance of this magnetic barrier becomes clear when considering neighboring worlds. Mars, smaller and cooler, once rotated vigorously enough to maintain a molten core and a global field. Over time, the interior solidified. The dynamo ceased. Bereft of magnetism, the Martian atmosphere thinned and vanished into space, leaving the planet exposed, frozen, and sterile. Venus presents the opposite extreme. Its rotation is excruciatingly slow, one turn every 243 Earth days, and retrograde, meaning it spins backward relative to most planets. This sluggish motion has left it with almost no magnetic protection. Dense clouds of carbon dioxide trap solar heat, creating surface temperatures hot enough to melt lead. Both examples demonstrate the same principle. Rotation speed influences planetary stability, atmosphere, and potential habitability. Here on Earth, the interplay between motion and environment is expressed not only in geophysics, but also in meteorology. Because the planet rotates, moving air and water are curved relative to the surface, an effect first described mathematically by Gaspar Gustave de Coriolis in the 19th century. The Coriolis effect organizes winds and currents into immense spirals, trade winds, cyclones, and ocean gyres that circulate heat across the globe. It gives hurricanes their rotation, determines the prevailing direction of ocean flow, and influences rainfall, climate, even the distribution of nutrients in the sea. The living world depends upon this constant redistribution of energy. Rotation does not simply move air, it moderates a planet. The speed of rotation also shapes the length of day, a defining constant for nearly all organisms. Every species on Earth, from bacteria to humans, possesses an internal mechanism known as the circadian clock, a molecular system synchronized to the 24-hour cycle of light and darkness. It governs sleep, feeding, photosynthesis, and the expression of thousands of genes. Even in isolation from external cues, these biological rhythms persist, drifting only slightly from the planetary period. When scientists simulate artificial days of different lengths, organisms struggle to adapt. Their metabolic efficiency declines. Life as we know it evolved under a single rotational rhythm and remains tuned to its steady beat. Rotation's biological importance extends beyond daily timing to the magnetic senses embedded in many creatures. Birds navigate by detecting variations in Earth's field, and migratory fish such as salmon rely on magnetic maps encoded in their bodies. These abilities exist only because the planet's core continues to turn. The slightest perturbation in rotation or magnetism could alter entire migratory routes, disturbing ecosystems on a global scale. The stability of life, from the microscopic to the migratory, is etched into the stability of spin. Yet Earth's spin has not been constant. Astronomical evidence preserved in fossil corals reveals that 400 million years ago, a year contained about 420 days, meaning each day lasted little more than 21 hours. Tidal interactions with the Moon have since slowed the rotation, transferring angular momentum to the lunar orbit and pushing the Moon slightly farther away, about 4 centimeters per year. This gradual exchange lengthens our days by roughly 1.7 milliseconds per century. The change is imperceptible to human senses, but measurable by modern instruments and even by centuries of astronomical observation. Time, in this sense, is an outcome of cosmic negotiation. Two bodies joined by gravity, adjusting each other's motion in a rhythm spanning eons. Comparing Earth with other planets underscores how delicately rotation determines environmental character. Jupiter, the largest planet, rotates once every 10 hours. Its rapid spin flattens the planet near the poles and drives immense jet streams that produce the striped bands and enduring storm known as the Great Red Spot. The chaotic beauty of those systems is a direct consequence of speed. Venus, by contrast, turns so slowly that its atmosphere circulates faster than its surface, creating conditions of permanent suffocation. Mars, similar in length of day to Earth, offers familiar rhythms of sunrise and dawn, but its weakened rotation and lost field have left the surface exposed. The fine grains of iron oxide that paint its deserts red are the mark of that erosion by solar particles, the silent testimony of a planet whose turn has nearly ceased. The interdependence of rotation and life inspires a broader reflection on habitability beyond Earth. Exoplanet surveys conducted with NASA's Kepler and TESS telescopes have revealed thousands of distant worlds, some orbiting within the temperature ranges favorable to liquid water. Yet when researchers model these planets' rotation rates, they find that spin often decides the outcome. A world that turns too slowly risks atmospheric collapse on the dark side. One that turns too fast develops violent weather and short, unstable days. Rotation defines the boundary between chaos and climate, just as it once did for Earth. Beneath these physical and biological mechanisms lies a quiet coherence. The same angular momentum that shaped the planet guides the flow of air, water, and magnetism, linking systems that seem otherwise unrelated. From the drift of continents to the glide of ocean currents, from the flicker of lightning to the opening of petals at dawn, nearly every process on Earth is modulated, directly or indirectly, by the rotation that began billions of years before the first living cell arose. The planet's spin is, in effect, the metronome of the biosphere. Rotation also endows time with meaning. Human culture measures duration in fractions of a day, the very unit defined by spin. Calendars, atomic clocks and the concept of the hour derive from the shadow's steady sweep cast by Earth's rotation against the sun's constant flame. Long before the invention of mechanical timepieces, ancient civilizations tracked this movement with sundials, water clocks, and the architecture of temples aligned to equinox and solstice. Our expression of time, therefore, is a human translation of planetary motion, a language we inherited unconsciously from the turning Earth. From the scientific to the poetic, it becomes impossible to separate life from motion. Every atom in a living cell vibrates, rotates, and aligns within fields sustained by rotation. A photon absorbed by a leaf is part of a chain of energy traceable through the movement of the sun, the spin of the Earth, and the circulation of atmosphere. The difference between stillness and vitality is rotation in balance, movement that is patterned, predictable, and enduring. Even rest depends on motion. When muscles quiet in sleep, the world continues to turn beneath them, maintaining the cycle that promises another sunrise. The story of rotation is thus a story of equilibrium. It reminds us that life exists not because stillness prevailed, but because motion was tempered into stability. A delicate compromise between momentum and friction allows continents to hold their place while winds travel freely. Were the Earth to halt, every ocean would leap toward the poles, the atmosphere would surge catastrophically, and the magnetic field would collapse. The planet would lose both its breath and its pulse. Motion, sustained and constant, is salvation. Many of the cosmic systems around us echo this same dependence. The moon's gentle torque keeps Earth's axis tilted at a steady angle of 23.5 degrees. That tilt, interacting with rotation, produces the seasons, periodic oscillations in illumination that govern agriculture, migration, and climate cycles. Without the moon's stabilizing pull, the axis might wander chaotically, plunging the planet into abrupt and hostile climate shifts. In this mutual dance of orbital and axial rotation, Earth finds the steadiness required for complex life to endure. Modern science continues to examine the minute consequences of this spin. Atomic clocks placed at different latitudes reveal that time itself varies with rotational speed. Seconds pass imperceptibly slower at the equator than at the poles, a confirmation of Einstein's relativity observed in everyday conditions. The very definition of time is entwined with the planet's motion, from cosmic beginnings to each tick of human invention. Through all these mechanisms, physical, chemical, biological, one truth persists. Rotation is not merely motion, it is structure. It shapes gravity's reach, magnetism's shield, the cycles of climate, and the rhythm of life's processes. Taken together, they form a planetary system sustained by a single continuous movement that began before life existed and will continue long after life has passed. When viewed in this light, the spin of Earth becomes more than a mechanical fact. It is a unifying thread connecting the birth of planets to the persistence of living systems. The planet's rotation is the script upon which biology is written, dictating the cadence of light and darkness, the temperament of climate, and the protective field that allows air and water to remain. Life is therefore not a random byproduct of motion, but its natural consequence. The next time the sun rises, the light will move across the horizon because the planet has turned, quietly, predictably, ceaselessly. Every leaf that opens, every tide that advances, every pulse that quickens in response to morning's warmth does so under the influence of that single rotation. The living world is inseparable from the turning of its foundation. Earth spins, and within that movement, life takes breath. The same rotation that shapes the day safeguards the planet, aligns its seasons, powers its shield, and defines its time. The calm we experience amid that motion is not absence of activity, but the harmony of a system in balance. As long as the planet turns, the conditions for life will persist, woven into each revolution of the world.